We're just having this conversation, Scott. We don't need to start because people just sign on whenever.
Okay.
So we're here talking, you know.
So
You know, I know.
that's your
What is it?
that's your cylinder.
Isn't that neat?
Yeah. Is that the one that just has slots on the side?
Yeah, this has it's made out of two half cylinders. See how I rotate
Okay.
it?
Yeah.
You can open it up to light it
Okay. Yeah.
like that. And there it goes. And there's two slits.
Okay.
glass.
Yeah.
There's two slits in the glass right there. So there it is. So it's got a slit up the side and a slit and the flame twist. And guess where I got this? Who would make such a thing? I didn't make this.
Oh.
Hey, we got some people enjoying us. Hello from Kentucky. Well, there he goes.
Do refresh.
Trose berry. Is that something like a gooseberry pie? Troseberry? Is that something like a gooseberry pie? Troseberry?
It's got
What would that be? Tros.
could be T. Yeah, T Rose. So it's
Oh,
Tim,
T Roseberry. Okay. I thought it was Troseberry. I didn't know.
Tim Roseberry.
Oh, Tim Roseberry. You dummy.
Oh.
I could have figured that out.
He was sitting right in front of my face.
Well, I'm just saying. Tim, I'm glad you're here. I'm particularly slow. Been this way since the accident. Mama dropped me on my head when I was a baby, and it's been downhill ever since. You doing, Scott? Scott, say hello to Tim.
Hey Tim, how are you doing?
Tim's here. Tim kind of classes up the place, man. In Kentucky. When's the last time you were in Kentucky, Scott?
Oh gosh. I don't know for sure if I've ever actually been.
Is Louisville in Kentucky? It is, isn't it?
Yeah.
Okay. Yeah, I've been there. Is that where they make the baseball bats?
Yep.
Yeah. Louisville Sluggers. Yeah.
Yeah.
Well, there.
I stayed in the hotel downtown, close to where they had the baseball bat place.
Oh. They do some big horse race thing there, I think.
Do they?
Something like
there.
that.
Yeah. Well, I stayed there, and anyway, I saw this thing. Way to start. We're just waiting on Kenny to get here. Kenny Luna. Kenny's coming in from New Jersey somewhere.
Oh.
That's what we're doing. And we got Tim. I like Tim. Put Tim on the good list. I called him a Troseberry.
No coal for Tim.
Huh? No coal for Tim. He gets a prize.
Okay, you never told me who made this.
Oh, yeah. Who would want to make it?
Well, I would, now that I know about it. I mean, I do it with wire screen and stuff, but
Yeah, I know
that's
why
way
it's green.
easier.
There's an official one made by the Zippo company.
Oh!
Why would Zippo want to make it? So you buy their fuel. Come on.
Yeah. That's what it runs on?
Yeah, it's got a little canister of gel.
Yeah?
Here, I'll tell you what. We'll turn it off. This is the way you turn it off. You open it up. It's got a little lid. It uses what do you call that gel?
Like
gel
Sterno?
stuff. Sterno, yeah.
Okay.
But it's official Zippo Sterno.
Okay.
I hope. So we'll
Sorry, I keep turning my head because I've got my YouTube channel on the other screen, and the picture is way better there than it is on Zoom.
No, I got news for you, Scott. You still don't look all that good on either.
I know, but
I mean, I didn't want you to, think.
you're always so kind, Jake.
Well, I try to be.
At least he's honest.
He's honest.
Yeah.
Now, do you think you can do this without burning yourself?
Probably.
Because I
I'm
don't
gonna
know.
just stick it over there or what?
How would a scientist tell if this is hot or not?
Back of your hand.
Yeah, back of your hand. All right. So you could pick it up like this.
Okay. Where do you want it?
Well, just over there somewhere.
Okay.
Well, I don't know where to put it. Our studio is so big and messy. I'm telling you. There.
I know, I always share the picture I have of it.
Well, I just don't like the smell of burning flesh. I mean, I don't care if it gets burned, but it's the smell that's distressing.
Luckily, we're not doing this on smell-o-vision.
Well, that's right. But he would have a thing. If you're not recording this, then this lawsuit wouldn't be so bad. Hot glass looks like cold glass. It does.
Yes, that's why I have Bunsen burner fingers from all those days in chem lab.
Yeah. Hey
where
Tim,
I
are
had
you a
kids
science
used to
guy
do-
of some sort?
Yeah, we always used to have kids bend glass tubing, and then they'd always bring it over. Mr. Capes, is this good? And they'd always be holding the cold end and hand me the hot end.
Oh yeah, hand you the hot end. Yeah.
And not even think about it until I dropped it and broke it. So.
Yeah. Yeah, I remember bending glass tubing and pulling pipettes
Yep.
and then blowing these great big bubbles. Remember those? Really thin glass.
Mm-hmm.
That shows your age, man.
Yeah, I know. And I don't think they don't do any of that anymore.
No, they don't do much of that. They want to get rid of Bunsen burners because
Look who it is,
they're
Jay.
dangerous. Huh?
Look who it is.
Who is it?
Muscle Car Pat.
Is Muscle Man back?
Muscle Man. Muscle car pack.
Oh, okay.
Can't stay for the whole thing.
You
but he
can't
wanted
say
to
the whole
hi.
thing. Well, say hi. I'm glad you're, man. I'm glad the sheriff let you out, brother. This is great news. I want you to meet Tim. Tim's in Kentucky. This is Muscle Car Pat. I don't know what he does with that muscle car. He might be a rum runner,
Uh-oh.
but you
Uh-oh.
know, but he tunes in to talk to the wizard, which makes him an esteemed, valuable member.
The science of running
Oh
rum.
yeah, I'm telling you. Let's see. I've got notes, gentlemen. Scott, we're waiting on Kenny to get here, but we'll go ahead and start without Kenny.
Okay.
He'll get in. He's probably doing something.
Rum running.
Because guys, what I do is we've got a lot of activities we want to put online, but I need to work out the bugs of each one of them when we do these
I
activities.
didn't realize
So
we had a
what I do is-
logo.
well, I don't want to just depend on, especially at my age, my wisdom. So I'll get guys like Scott and Kenny Luna. Scott's a very distinguished. How long have you been in science education, Scott?
Oh God.
Including the
Since
time you were
83.
in it when you as a student. Go back.
Oh, is it?
Yeah,
How long?
when did
How
you-
long is this? I'm still a student of science.
well, I'm just saying.
Yeah. No, let's see. I started almost as long as I've known you. Actually, 4 years longer.
Well, we're talking about half a century.
Oh yeah, easy.
Man, you guys looking there,
Muscle Car
Pat
Pat.
and Tim are looking at these fossils of science right here. I gave my first lecture in '64.
Oh.
That was a long time ago. How many years is that? 62
Longer
years,
than I've been alive.
62 years ago. Yeah. That's a long time ago. They thought I was a student teacher.
Yeah.
I was a lab assistant, right? And I had a key to the storeroom, and they had a student teacher in, and then that person got sick. The substitute instructor got sick, and the student teacher took over, and so they thought I was a student teacher. They didn't know because I was a tall kid, tall student. So they thought I was teaching. So for a week, I taught the class. They didn't know. What can you do? What can I say? Well, here we are. What's been going on in your world, Scott? Firstly, I've got 5 pages of notes.
Oh wow.
Ready? So first question, what's been going on in your world?
We got National Teacher Hall of Fame inductions this week in Emporia.
Really?
So yeah,
There
we got
is a national, what is it, national?
National Teacher Hall of Fame. It's here in Emporia, Kansas.
How do you qualify to make that? Is it like
Don't even
voted?
You get-
ask. It's
You
beyond
you get nominated, and there's a selection committee that looks over your nomination. So
Wow. Hall of Fame, man.
I am not a member of the Hall of Fame, but I've helped out there a lot. So
Yeah. Hall of something.
but they actually this year they induct 5 people every year, and I think 3 of them are middle school science teachers. I haven't had a chance to meet them yet because they
Well,
just
that's
got
great.
here last night.
All right.
So
Well, I've been working on the Faraday 200. And for Pat and Tim, we've gone through our collection here and picked out the best of the best that we've got, and we're putting them together in a cluster called Faraday 200. And the United Nations is going to distribute them around the world. Can you believe this? This is great. Oh, hold that up there. Look at here. There's Faraday
Oh, is it upside
200.
down? Oh.
Is it upside down?
No, it's good now. It might have been earlier.
Okay, Faraday 200. So there it is, man. We even got a logo, Faraday 200, named after Michael Faraday, of course. So we've been trying to come up with a method to get young people interested. And one thing we've been working on lately is, did you get a picture of the Tinker table? Are you ready for this, Scott?
No, I saw it when I was there when they were first putting it together.
All right. You want to see the finished product?
Yeah, definitely.
Da, 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 da.
Oh, wow.
Look at that sucker. That is a homemade built by kids, of course. A place to tinker. Because what we're trying to get young people to do is to tinker. I don't want them to learn science yet. I want them to enjoy the craft of the art of messing with stuff and using their hands and not referring to their cell phone or computer or whatever. So look at the signs we had made. You ready for this? Look at that one. Critical tinkering. There it is. What's the other one say?
Danger
Danger.
with
Okay.
a bomb.
With a bomb. These are the signs we're putting on their tinker stations. What's another one?
Caution, unpredictable reactions. Keep
Yeah, get back. Now what else we got?
clear. Warning, mad scientists
Yeah,
at
see
work.
there, Scott. Mad scientist at work. Stand back. And what else we got?
We got one more, tinkering in progress.
Yeah, warning. Tinkering in progress. Stand back. So we're trying to build an atmosphere that young people might enjoy. Like they're doing something in the basement they shouldn't be doing. Or something like that. Did you ever mess around with stuff when you were a kid out behind the
Oh,
garage?
God, yes.
So what did you do? You remember?
I remember my brother and we had I forgot where we got the little speakers from, but we had 12 speakers strung around our bedroom hooked up to the radio.
Really?
Yeah, and it didn't blow up, and we didn't get electrocuted.
Well, there you go.
Win-win.
So, yeah, just odds and ends, stuff like that.
Yeah, well, I did too. I tinker with a lot of stuff. That's great. See, Tim, he loves
Tim gets it.
tinkering in progress sign. See, Tim's our kind of guy. Welcome, Tim. We just got to grow the group. Anyway, tinkering station. So I'm going to by the way, I'm going to give you an appetizer before we get into the main course, because we're going to do some demonstrations here, Scott, and then you're going to give me your input how we could improve these before we show them to young people.
Okay.
That's what we're doing tonight, Tim and Pat, and whoever else joins, is that we are kind of prototyping some of the demonstrations we'll be doing down the road and get input. And you got to stay sober for the next 90 minutes.
I'll do my best. And I can't make any
just
promises.
work on that, man, because it gets embarrassing.
I know.
But his jokes get better as the evening goes along, right?
Yeah.
You know what I'm saying? So I want to share something with you while we're waiting for other people to sign up. I pull things out of our collection, and I found these. These were mine in 1952. Do you remember these things? Building blocks?
Okay.
They're little, this is what's funny. They're little building blocks that snap together to build things, right? Are you with me?
I don't want to alarm you, but they look a lot like Legos.
Oh, no.
They sound
But they're not
like
Legos, I realize
They
that.
could not be. Now, I want you to see the name of the company that made these in 1952 when I got these as a
A
kid.
little bit.
Right there. Who made these things?
Elgo?
Elgo.
We're 3/4 of the way to Lego.
Go figure. 1952 in the U.S., we had Elgos, and they didn't sell too well. I mean, they had a few of them around when I was a kid, but all you got to do is move a letter around and you got Legos.
Billion-dollar company.
I don't know.
So,
I'm sticking with my Elgos. Here, get those out of the way. Used to build things with that. What else did I find upstairs in the storage? Oh. I want to share with everybody. If you go to Physics Today, which is a magazine, you can read this online. This is last month's edition. Physics Today. It's put out by the Physics Teachers Group, right? But you can read these online. This whole issue just came out. It's from Oppenheimer and his thoughts about the atom bomb. And man, you got to read this. This is like, wow. In his own words, it's called. So I just finished reading it. I got it online, then I ordered a copy of it.
Okay.
Well, what was the man thinking when he was building the A-bomb? That's really wild. Let me put that over there. What else did I find upstairs? You know, we have the world's largest collection of science education stuff right here. Did you know that, Scott?
Oh, I did know that because I've looked through it.
Yeah, it's the largest in the world. So I just went over and, oh, no, you went and got this, didn't you?
Yes,
You
picked it
picked
out.
this off the shelf. This is Beckett, my wizard in training. Got this book. It's in very good shape. And I think this belonged to Wizard 2, not Faraday, because it was published in 1772. No, 19.
I was going to say that looks.
Oh, shut up. I can't read. Okay,
Before
don't make
America.
Don't make fun of the old man when he's down, right? 1876.
Okay, yeah.
150 years ago.
I know, it's close enough.
Yeah.
18. But this one is called The Nature of Light. What they knew about light in 1876. And they just discovered this new thing. Are you ready for the discovery?
Yeah.
Right here it is. They put it on the inside of the book. That freaked everybody out. Did I lose it?
It's the next one.
Yeah.
Next one over. They found out that
Oh,
different lights would have different spectra.
okay.
That was pretty exciting stuff.
Huh.
Look at that, Scott. That's amazing,
Yeah.
isn't it? Look at that, baby. They were starting to identify the spectra, and they were all excited about it. So it's fun. It's a fun thing to read. I haven't read through the book, but it was just they were just discovering things, and they got all excited about it.
Does it say who did it? Who wrote the book?
Oh, it was a group of scientists.
Okay.
I'll find out who it was. It's 14 chapters. But this is the part that I like because, you know, I'm always talking about the hardest thing about teaching science is math gets in the way the first time through. You start throwing the numbers out.
Yeah.
Acceleration of gravity. What's gravity? Well, 9.8 meters per second squared. What the heck does that mean? Per second squared.
I know. Too many
Does that
numbers
make
for
any
me.
sense to you?
Not at all.
Per second squared. So the math messes you up a little bit until you get into it. So this is what the guy wrote. Mathematical reasonings are wholly omitted in this text. That's really funny. Because I don't want to read the whole thing. Because they are undesirable at times. Well, I won't go ahead how he cusses at it, but he's saying math is undesirable at times. I thought that's pretty cool. But you need to get the phenomena described to you clearly before you add math to it. And I thought that's brilliant. So that gives enough credence to what we're doing. We're saying we're teaching science without math the first time through. Later on, we add the math. And I know the math teachers say, hold on, Jack. Don't do that. And I say, well, we'll get the math in there, but later. But this is the one. You got this off the shelf, didn't you?
Yep, found it up there.
You're not going to believe this one. You ready for this? Do you see what it says, Scott?
Oh, yeah.
Have you seen this book?
I have not being an American Girl.
You're halfway
Now,
there.
you know, don't say that thing to me. Let's line up too many jokes. Okay. The American Girl's Handybook of Science and Other Things.
Oh, it is of science?
But it's handybook. So there's a whole bunch of science activities you can do in there, right? For girls.
Oh.
But there is a warning, because you know most of the things you got to have a warning, right? Yeah, okay. So this is from Dr. Edwin Clark, a member of the Harvard University Medical Faculty. Ready? Author of the 1873 book, Sex and Education, or A Fair Chance for the Girls. Have we heard this argument lately?
Actually, we just had it a little while ago.
Well, that's what I'm saying.
Yeah.
Girls should not be trained in science because they are in grave danger of physical and mental ruin. The reason? The female body, with its limited available energy, could not successfully meet the physical demands of puberty while also enduring the mental strain of scientific study. Something would have to give. And what generally gave were the reproductive organs.
God.
Case studies of Vassar women provide scientific evidence that too much study, and certainly any attempt to match male educational achievements, would sap the developing female organs, leaving girls weak, nervous, and sterile. So girls should not study science because it will leave them weak, something, and sterile. Nervous.
I'm going to really assume you have not shown this to your wife.
No, but I did show it to one lady at the NSDA convention, and she and a very renowned. She was a Mr. Wizard fan, and she signed it. I asked her. I said, Sally, would you look at this? Her name was Sally Ride.
Oh my gosh.
So it goes, BS, wrong, Sally Ride, SR. She didn't want to write out. Can I say BS on the? I better not because I might offend Tim.
Beckett, do you know who Sally Ride is?
I've heard of her once or twice.
You know what she did?
First woman in space, right?
First woman in space, I guess, right?
Yep.
Yeah, first woman in space. Looked at that, and she couldn't stop laughing and choking on herself. But I asked her to comment on that, and she goes, bullshit. So we have it right here in our library. Sally Ride, be writing the book there. What is it? Bull sharks. That's right. Thank you, bull sharks. That's
Hit the
what
nail
that
on the
BS
head.
stood for. Bull sharks. Put that back in the sacred vault. We got to do some stuff for these people that came in here all the way to do this. Okay. Would you grab that box down there? I'm going to
Yes,
show
sir.
you one more thing from our collection before we start doing some demos. Do you have any idea what that is?
Not at all.
Forget these things out of the way.
Okay.
Scoot around. I don't know. Is that okay there?
Yeah, that's fine.
You got a good? Have you ever seen anything like that?
Nope.
How old are you?
16.
He's 16 years old. He's never watched any Roadrunner cartoons. Can you see it, Scott?
Oh yeah, I know exactly what it is.
And look at Scott. He's an old man.
Scott's got it down.
Hey, any of you guys online know what it is? Show them that right there. It's got a handle that goes up. Can you push down on that
Yeah.
for me? Yeah, it got a handle that goes down. They're thinking, have I ever seen anything like that? We've got a couple of them in the collection. You've never seen that?
Come to think of it, I think I saw something in Davy Crockett that looked like that.
What is this?
Is it a detonator
A detonator?
for like dynamite or something?
Like dynamite or something? Yeah, it's a Acme igniter. Hey, there's Blazer 5114. Yes, it is. The Roadrunner Acme. And I'll show you what it does. Here I've got, is this one good, Cody?
Yeah.
Why don't you wire that one up right there? I've got a little, what they call a squib. If I was going to set off an explosive charge. So right here is a little squib that would, I don't know what it's going to do, but you're going to lift that up halfway. And give it a shove down. 3, 2, 1. There you go. Whee! That's pretty cool. It works, right, Scott?
Yeah.
Should I undo
Oh,
this or keep it?
and it just keeps working?
Well, that was just smoking. Did you see it?
Single shot.
Did you see it fire?
Yeah.
Okay. So we're done with that. The question is, what's going on inside there? What in the world is going on inside that box? So I just want you to ponder that over a few minutes. So I would start this with kids. Is it okay to show this to children?
I don't think they're going to get their hands on one.
Is this terrifying with all the terrorism in the world? Can I put this on? What would you show it?
Oh, I would in a minute, but
It's
I
not
don't know if
gonna
you get a
lead- it's not
first-year
gonna lead
teacher
you
to
to
do
blow
it.
something up, is it?
I think a lot of people would lack the means to blow something up, but I don't know, maybe.
But see, everybody I know would like to try it. They'd like to. Have you ever
Mm-hmm.
plunged it? Have you ever operated one?
No, huh?
And you want to, don't you?
Well, yeah.
Well, see,
What I really
that's
wanna do
my
is
kinda
I wanna
guy,
hook a
right.
volt.
You got it. That's
I want-
what it is.
I want to hook a voltmeter or galvanometer up to it
Well, yeah.
to see what's coming out of it.
See what's coming out.
Did
of
he
it.
say galvanometer?
Galvanometer. I don't know something else. So set that thing down and let's move on. We'll come back to that later. I just wanted you to think what could be going on inside that thing. Okay. Okay. So tonight we were going to talk about. Oh, I got to tell you something, Scott. So 2 weeks ago, do you attend the National Academy of Science things online at all?
Not really, no.
No. So they have the annual, like the State of the Union. You know, the president does State of the Union.
Mm-hmm.
State of the
So
science.
State of Science
Oh,
by the president of the National Academy of Science. And she's the queen bee of the world when it comes to science. National Academy of Science. And I presented there at the NAS a couple of times years ago, so I'm still on their mailing list. So I got invited to come there and sit, but I decided to watch it online. And they sit down and explain what's going on in the world of science, and then they come to science education. You know, what's going on? What's the big needs? What are we doing well? What are we not doing well? What do we need to do? What do you think the number one thing at the National Academy of Science it said that we need to inculcate in our young people in science education? They had a whole list of things we need to do, but the number one at the top of the list, what would be the outcome we would hope that our children would get from having a scientific education at the National Academy of Science?
yeah.
The very thing.
I would hope critical thinking, but I'm not sure if that's it.
That was it.
You're kidding.
Hold up the
First
sign.
try.
Where's the sign?
Oh, well.
What'd you do with the sign?
Which sign? Oh, over here?
Critical thinking.
Tinkering?
Yeah.
Oh, it's over here.
Grab that. The entire National Academy of Science, Scott, gave us a thumbs up without even knowing it.
Right here.
Can you believe this?
How do you like them
I about
apples?
fell out of my chair when I heard her say that. And if you go online and listen to the State of the Union of Science, right in the middle of it, she goes, the number one thing we have to do is build critical thinking.
Thinking or tinkering?
Thinking.
Both.
Thinking. But that's our spin is we're going to get them to tinker first so they can learn to think. Isn't that cool?
Is that tinkering builds critical thinking?
That's true.
Right there it is.
That's why we have him.
That's why we have him.
Yeah. So I get the big money.
Okay. So all the things we're going to do now, these demonstrations we're going to do, have something to do with electric current. So what things can we do with electric current? What can we do with electric current, Scott? What can we do with it? What can we do?
Oh my gosh.
Just give me some ideas. What can you do? You got a bunch of electrons. Now, what are humans able to do with it?
Run them through a pickle.
Run through a
Oh,
pickle.
yeah.
We saw that. We saw that. What else? But in general,
got-
not specific. We can.
Oh, okay. Not as specific.
Yeah. Can we
Well,
capture them? Can we capture them?
oh yeah, yeah. That's why you have Leyden jars on your table.
Can we move them about?
Well, to make them current, yeah, they have to move.
Can we speed them up?
Ooh.
Can we slow them down? Can we stop them? Can we manipulate them?
Yeah. I know we can stop them. I'm not sure about the speeding up and slowing them down, though.
You see what he's doing right now? You see? Hey,
He's thinking.
He's thinking.
He's
That's,
thinking.
That's a scientist, see, right there. That was
Take
it.
notes.
That's all we want to get young people to do. How would you capture an electron that's so small? How would you move it about? How would you juggle it? Could you
And I
make
guess
a new trick?
I guess the other thing is, how would you know if you had it or not?
Well, I know. So some of these activities will demonstrate, hopefully, not high electronics, but the idea is that, we can manipulate electricity. Even though electrons are so small they're almost not there. Some people say they're not there. There's a knot of light. But we can manipulate those like a juggler. You know, we're electron jugglers.
Yes.
Can you juggle?
No. Two, not three.
Okay.
Not even.
Juggle.
Not
I
even
can juggle
juggling.
one ball.
Yeah.
I'm good at that, man. I'll tell you. Well, anyway, I was going to have a juggler here tonight, but none of the guy that worked for me can juggle. So I've got a device. It's in the collection that it manipulates electrons. I think, and it's about 100 years old. It's celebrating its 100th anniversary today.
Ooh.
But you know where it's right there on that shelf by that doll's head.
Oh yeah.
You see that copper-looking thing?
Yep.
Bring that over here. So there it is. Does anybody recognize that? Scott, do you recognize that?
I know I should because I had like 6 of them in my lab at one point.
No kidding, you had 6 of these.
Oh God, yeah. When I taught, well, no, even when I taught high school science, yeah. I know I always had a couple.
Hey, Blazer or Tim.
Tim.
You recognize what that is? It's 100 years old. It has something to do with electricity.
It's made in USA.
It's made in the USA, man.
Get up tighter on it, Cody.
It's got a couple of prongs up here. What do you use those prongs for? You know what those?
I don't know.
You know the name of these things, Scott? These things have a name like Klingenthal or something. There's a name for these.
Is that
things.
it?
It's got a fancy name.
Okay.
You
I would have just called
hook
them
wires up,
spring connectors, but
Huh?
I thought they were just spring connectors, but
Spring connectors. Yeah, they've got some.
yeah, they probably are named after some famous.
Blazer has
Fun
nice.
spring or
Is that a
something.
Fauna stock clip? I think it's a Fauna stock clip.
Okay.
Make a liar out of me.
Look
I
what,
don't know.
look what Blazer said.
What does he say? Solenoid for a telegraph. Man, these guys, see, they're getting there.
Okay.
Blazer, you're just bouncing off of it. This is they call it a vibrator, a vibrating coil for a Model T. This is the coil that makes the spark
Yeah.
for a Model T car. Put in 6 volts, you get 6,000 out.
Mhm.
No, not that many, 2,500. They had 6-volt batteries. You get 2,500 volts. Somehow, this device turns 6 volts into 2,400. And you know what they call something that does that?
Multiplication.
If you change something, change the voltage.
Translator.
A trans, so it's trans. What is
They have a bunch of movies about them.
Transformer.
a
There you go.
transformer? There it is, man. You're a
Yes.
good wit. One of the first transformers is this Model T thing, right? You got that?
That's why I had a bunch of them.
Huh?
They must have gotten them from a car dealer back
Is
in the
that
day.
what it is? Yeah. Yeah, back
Yeah.
in the 20s.
I actually have one on my tractor. I didn't even think about that.
Okay, well, that's a transformer. We might fire it up. No, matter of fact, I think we're going to go bigger than this, but I just wanted you to see that these have been around for a long time. That's a transformer. That'll turn. But how in the world would it turn 6 volts into thousands? What could possibly be going on inside here? What do you think? What would be in? How would you take 6 volts and turn it into 2,000?
I have no idea.
That's kind of scary. Do you know, Scott?
Yeah.
Yeah, I know the mechanics of it, but why does it do it?
It has to do with because you have 2 coils
Yeah, I know
of
it's got 2
wire.
coils.
Yeah. And
Primary, secondary.
yeah, and your secondary core has, what did we say? It's a 6 to 20. You said 20. It kicks it up to 24,000.
2,400. Yeah.
2,400.
Yeah.
So it'd be like, for every 1 coil in the primary, there'd be 800 coils on the secondary.
or something like that, right?
Yeah, something. Oh God, I'm doing math. I'm sorry.
No, it's all right. Well,
Can't-
whatever
can't
it
do
is,
that.
but one coil has a few wraps of wire, and the other one has a
Right.
bunch, right? And that builds up. They call that a step-up transformer, right?
Yeah.
Now, what's going on in those coils that would make that happen? Just wrapping coils of wire would make bigger voltage. Say, what the hell is that? So that's the kind of thing we're trying to do, is to get kids to figure out in their heads, can you actually make electrons do that kind of dance? Obviously, it's got to be simple, because this is just a wooden box with some stuff in it. I don't think there's any moving parts in here.
No.
So
Just
somehow,
the electrons.
yeah, if I open this up, which I won't, you're right, I would see thousands of wraps of very fine wire and just a few wraps of the primary coil. I didn't want to cut it up to see it. Okay.
I guess the hard part is, how would you get kids to go in and start thinking about induction?
That's the problem. Is that why
Yeah.
do I even get interested in this? You know, it's tough. Let's see. Would you go over on the top of our valuable chest over there? You'll see something with coils of wire on it. Scott, that's the cabinet where we keep all of our beautiful things. Let me get a drink of water here. Ooh, you found it.
First try.
First try. There it is. Okay. Had to get a drink of water. I don't know if you can see it or not. Do you know what this is, Scott? What does it look like? to
Is
you?
that your Faraday motor?
Close?
Halfway there.
Oh, or is it Tesla?
Yeah, that belonged to Nikolai Tesla.
Okay. Oh God.
Isn't that amazing?
Yeah.
And he developed the three-phase motor.
Mm-hmm.
He did kind of the opposite of a transformer, you know. He did, but he used coils of wire. And there are three different series of wire. There's the yellow, red, and green there. That's a three-phase motor, 3 sets of coils.
Mm-hmm.
And on the inside, on the wheel, there's a coil of wire wrapped around this center part. So I've got a coil of wire spinning. It spins. And there's a coil of wire on this armature here. And what's around the outside?
More wire.
More wire. That's an electric motor. Are you kidding me? Coils of wire make a motor? Is that it?
Yeah.
Is that all there is to it?
Mm-hmm.
I think this is probably the most valuable thing we have in our collection that I inherited. The Wizard thing is this belonged to Tesla, and they built a few of these. These were patent models to demonstrate a three-phase motor.
You ever run it?
One time, Mr. Wizard did, and we were nervous, and it works. But I'm sure not going to burn it up.
No.
You want me to run it, don't you?
I really do. I really want to see it go.
Someday before I die, we'll get it going.
Okay.
I just thought, Jake, if you screw this up,
Oh yeah.
moron. But can you see that, buddy? It's got coils of wire
Yeah.
inside another set of coils. Isn't that amazing? And that's an electric motor. And all electric motors have something similar to this, not exactly like it. But somehow we've got these coils of wire making this coil turn. How would you get a coil of wire to make another coil of wire move?
You have to charge it, right?
Yeah. Do you think well, they run electricity through it, obviously, right?
Mm-hmm.
So something happens. You run electricity through the wire, and this thing starts turning. I wonder how that happens. And who cares? Whatever. Anyway, I want everybody to see this. The idea is we're trying to build this up, and this is not a good science lesson. I'm just listening for input about what questions would I ask about this motor. You know, what would I want a young person to remember after they saw it? And you say, boy, electric motor isn't all that complicated, is it? It's 2 coils of wire, or 2 sets of wires. Can you believe all that? I mean, you look at all electric drills and electric motors, you say, man, that's so complicated. And I say, but you know, in reality, it's very, very simple. 1 coil of wire moving inside another.
Mm-hmm.
And that's why I have to take my hat off to people saying, you know, some scientists figured out how to get to talk these wires into moving. We had to figure out how to manipulate the electrons in such a way that they would make this thing turn.
Look, Gerbil said science is tough.
Yeah, it is. Sometimes it is. It depends when you come in the movie, Gerbil. That's a good name, Gerbil. They call you Gerb for short.
I guess.
You come into a movie plot, in the middle of the movie, it looks pretty complicated.
Yeah.
But once you see the whole thing, the whole story, it's not that complicated.
Yeah.
But you said that, but I don't want that getting broken.
Yeah.
So we got to start doing something interesting. I've been talking too long. Okay. Let's see if we can manipulate some.
Should I go get the ice?
Huh? Oh, we have to do that first before we get into this. You go see if the ice is frozen. I'm sorry, we're taking an interruption, Scott. We'll come back to electricity in a moment.
Okay.
I've got to see if this works. Oh, okay. We'll get that in a minute. So, you know, we were watching the Winter Olympics a couple of months ago, was it?
Mm-hmm.
3 or 4 months? When was that?
February.
February.
It's like kind of frozen. It's
What
not,
is it?
The top layer isn't all the way set yet.
It isn't set yet?
It's close.
Well, why don't you just pour that water off
Okay.
and bring the rest of it in here. See, now my wit was supposed to bake the cookies for the show, right?
Mm-hmm.
Yeah, I didn't do it. Just dump it on the floor there. We'll have to see if this works. I think we screwed up. Okay, come on. Here he comes. Here he comes. Bring that in here. I'll dry it off. We'll just see if this works. Oh yeah. I've got a sheet of ice here. I'm gonna dry it off. Oh yeah, it's frozen. Remember what we saw in the Olympics?
Yeah.
What did they do with a sheet of ice besides ski on it?
Well, they played hockey and they curled on it.
They curled?
Curled.
Okay. Have you ever curled, Scott?
No.
That surprises me. Scott, he
never
struck me as a
curled.
curler.
Matter of fact, I'm going to dry this ice off with my ice dryer. Okay. Yeah. It's not
See
frozen,
what I
is
mean?
it?
No, the middle's not.
Okay, it ain't gonna work. Okay, gotta put it back in the freezer. Dang it. That's what happens when you get a wit to do something. Give me that. This is what I found. I found a curling broom.
Oh.
You see that?
Yeah.
I want to see if it actually works. We're gonna see. I want to see if this actually melts the ice when you go take the curler across there. But I screwed up. So
I mean,
put it back in the
should.
freezer. Huh? But I've never seen it. Have you ever seen it?
Yeah. No, I mean, not in person.
Yeah, I just watched it on TV.
Yeah. But it does make sense.
Well, but
Like,
I've never seen the ice melt. I've never seen it. You know, this
We
goes
don't
across
see it when they skate either, really, because it freezes right back up.
Well, that's it. I've never seen. Have you seen any of it? I've never gotten down with my face against the ice and seen it.
Well, yeah, I've done that when I've ice skated, and you can tell that it
Well, I know.
refreezes.
Okay. Well, anyway, we'll wait till that freezes. It might freeze. We'll be here a little bit longer. We'll keep going. Probably have to freeze that for 5 days. We'll have to shoot it next time. I've been putting that off for like three visits. Should have started earlier in the day, shouldn't we?
Yeah, that's my bad. I shouldn't have added that last layer.
What'd you say?
I said I shouldn't have added that last layer.
Did you say my bad?
Yeah,
Okay.
mine. My fault.
See, tell that to Mr. Luna. He just
Mr.
turned
Luna,
in.
it's my fault.
It's my fault that I did not put the ice in soon enough so I can impress you and get you to smile. That's Kenny Luna.
That's our whole goal.
That was the whole goal. And Kenny Luna does not smile for just about anybody.
Yeah.
You doing all right, old man?
Yeah, I'm doing good.
Would you do
No
anything
complaints.
worthwhile?
No, I'm just doing my thing.
Okay.
Winding down the school year, you know what I'm saying?
Yeah.
We
Well,
got
we're-
finals tomorrow, and
Is school just out for you?
school will be out next Friday.
Oh, wow.
Oh, wow.
Yeah, we're not like you guys. We run later, but we start later. We start in like
That's right.
August 30th or September
Is that
1st.
a public school district?
Yeah.
Yeah.
They're tough up there. He comes on the side. He comes from the part of the U.S. that they'll take prisoners up there.
Dang.
Or the kids are a little not quite as bright. They have to be in there longer. There's another possibility.
Well, like I said, we go back later. You guys go back mid-August, I think, don't you?
Okay.
Yeah.
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 We go back around
They go
second
back
week of
around-
August.
yeah, Okay.
Yeah.
Okay.
You know-
So we are going to try something. Let's get that little where's that little Whedon transformer, Scott? The little handheld thing. Cody.
The little handheld.
Yeah,
transformer
the
control?
right there.
This one?
Yep,
Yeah,
that's
bring that
okay.
over here.
Oh, the Odin coil.
Yeah, the Odin coil. It's Whedon coil. Okay, so we're just going to start with this one. Oh, there, and go in that disc. And you know, there's a little bitty doorbell transformer over there too. You see it over there on the workbench?
Yeah.
The lights. Grab that little bitty doorbell. Yeah, there you go. Bring that over here. So here we are. We have an official transformer. There it is. It says right on there, transformer, right?
Somewhere.
Yeah, somewhere, transformer.
Yeah, on the top.
That doesn't look anything like the ones in the movies, Jake.
Yeah.
I know.
That's not Optimus Prime.
So what does it say on? Does it say anywhere what the input and output is? There's that. Let's see. Input is what?
120 and 8.
And what's the output?
8.
8.
Yikes.
So 120 volts. Will that kill you or burn you? Right?
Yeah, probably.
Yeah, that's pretty mean stuff. 120 volts out of the wall socket turns it into 8 volts.
Well, what do you want to do that for?
There you go. The question. Look, they built the darn thing and made it nice and slick and everything to do that. Why would you want to go to the trouble of turning 110 volts into 8? So how would you ask that? How would you ask that to students to make it? I mean, or would they even care?
Well, I don't know that they would care. I think that what I need to do is show them something that uses only 8 volts and explain to them why. You know, I don't know. In a perfect world, you could show them what 120 volts will do to something that only wants 8. But I'm not
Might
sure.
only do it once.
I was
I could
gonna,
do
well,
this.
that's the thing. I mean, I'm not sure that that's the
I could
wisest
lick this
choice.
in and see what happens, and then lick this in and see what happens.
That's what you could do. That would certainly catch their interest.
Yeah, that's the trick. Is how do you get kids interested in this enough to care to want to know how to figure it out?
Yeah.
What spin do I put on it? That's why we're having these meetings, by the way, Pat and you guys. Is how do you get kids interested enough to even want to pause and consider it without going, meh? Is that your word? Your generation?
Yeah,
came up with
it's meh.
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 Meh. The whole world is meh. How to make a transformer. The whole concept of transforming, interesting.
Make a movie out of it.
So that's our purpose tonight, was after playing around with all this stuff, is say, just this one point, how do I capture their interest to say, oh, do some more of that. Do some more of that. More. So I could wire up a doorbell to this, right? Make it ring. And that wouldn't be much, would it? I mean, that would just, that ain't going to do it, is it? Hey, you can
Probably
make the doorbell
not.
ring. See, I'll put up a bell and a circuit and go, hey, ring, ring. What did you do at school today? I pushed a button and made a doorbell ring. I don't know if that's going to do it.
Life changing.
It's not life changing, is it?
Nope.
That's why you're here. Check that. But now this device, oh,
That looks life changing to me.
it's got the same plug. Look at here, same plug, right?
Yeah.
What's it say output is on this? Oh, wow.
How many thousand?
Warning, huh?
Warning.
35. It can't be 3,500 volts. Would that
Oh, yeah, it
sound right?
can.
3,000
It probably is.
volts?
Oh yeah.
3,000 volts. I'm gonna plug this in.
Okay.
Let's see if I can fire up 3,000 volts. Yeah, 3,000, man. Oh, I got turned on. Oh, did you hear that?
I did. That sounded dangerous.
That doesn't sound good at all.
Nope.
Do you want to touch that?
No.
Can you hear that, Scott?
No, I couldn't hear it.
No, I can't hear it at all.
There's no way to hear that, is there, Scott?
Doesn't sound.
Yeah.
Yeah. I know the sound it's supposed to be making.
Now the deal is,
What is it?
There you go.
What's what? Well, good God, Jake, don't put it up against your microphone.
Zap the microphone.
that
There.
sounds like an electric razor,
Yeah.
and you can't hear it over the thing, can you?
Now I can hear it.
There, I can hear it there.
Right
Yeah, there I can hear it.
Can you hear that?
Oh, we just
Oh,
lost.
shit.
We lost the TV. Never mind. We're good. Never mind. We're good.
Did I make the TV go off?
Probably.
No.
Wasn't you did that last time too?
This is cool.
Zap the TV.
I mean, I turned off the TV. Can you hear me, Scott?
Yeah. I mean, and the YouTube's still going, so.
But just for a second, the screen went blank.
Oh.
We're good now.
Why is that?
No.
Yeah, he's one with the thing.
Now look, I'm gonna do that again and see
Yeah.
what happens. You guys didn't see the TV go off,
No.
You really can't see the TV.
but we did. It went off.
Did
Killed
it
it.
come back on?
Yeah, it's good now.
Oh, Blazer's checking out. See you, Blazer. I know this isn't too exciting because we're trying to be good science teachers. The guy said, "Yeah, good luck with that, you poor guys." There we go. There.
Oh, got it again.
Hmm.
It went
But
off.
the TV, but you can get the TV back on, right?
Now it's
Yes,
back
it's-
on, but it went dead as soon as I made the spark.
Huh.
And who laughed? Who was doing the laughing?
They played a sound effect.
Your button.
Oh, you hit the button?
No, it
Oh, it triggered the button.
This is all messed up. See, I've got some buttons down here that,
That's
Oh.
hilarious.
see if I can find it. See if you can hear this. You can. Can you hear that?
Barely.
I have a flatulating desk. I have a button under here that will make the
Oh.
desk flatulate. See, when people,
Who thinks of putting that kind of thing under a desk?
I don't know.
Dr.
but
Steve
when
Jacobs
people-
apparently
when people-
does.
Apparently.
When people are sitting across from me, you know, and a conversation kind of goes downhill, then I'll just tap that, you know.
Oh.
That's
Does that
terrible.
signal the meeting is over? Is that what it is?
No, but now how am I supposed to demonstrate all these sparks?
Well, it's still everything else is still working. You just can't see it on the TV.
Okay.
But I mean,
Yep, keep
I'm
zapping.
wondering if it's doing something for the remote control receiver on the TV,
Okay.
because
Now,
the
are
TV
you-
comes
did
right
you-
back on.
Did you see the spark on this thing? Or on this?
Yeah.
Okay. So now we know this puts out.
Jake,
Huh?
want to do it one more time so we can see the TV go off?
Zoom in on it, Cody.
Not just the TV?
Oh, guys, zoom in on it. There he is. He's zooming in
Like, that's just out of context. But
Yeah.
out of context. Now I'm going to turn on the spark.
Oh,
Didn't do it that time.
Didn't do it that time.
I'm going to move it over here.
even closer. There we go.
Oh,
Got
there
it.
it went. Went
Yeah, there
blank.
it goes.
But then it came back
Oh,
on.
there. Okay. There's a
It scared
delay
me.
on the
I thought
YouTube
I
part.
thought I
so-
just killed somebody or
See,
something.
now we know you can use your transformer as your TV remote.
Yeah. Yeah.
Oh my gosh. It messed up my whole thinking. I thought I killed the whole thing.
Yeah.
So what?
But it must be putting out some infrared that the remote receiver on the TV's picking up, and it's
spark
the
is.
signal to
See?
turn it off.
Yeah, what it is.
Why
It's
infrared, Scott? What's that about?
Because that's how your most of your TV remotes work on infrared.
Yeah.
That's one of the fun things I've done with kids. I have a night vision camera, and I'll hook it up, and if you push a button on a remote while you're pointing at it, you can see it flashing because it's infrared, so you can't see it with your eyes, but the night vision camera will pick it up.
Did you go get that alcohol bottle and
Yes.
stuff? Go get that. Well, the idea is that sometimes we want to make higher voltages
This one?
other than 110 for a useful purpose. I mean, why would you go to all this trouble of
I
making
know what the practical use for it is in the real world.
Yeah.
I mean, I thought they used to check for gas leaks.
Okay.
They do, don't they? Well, here, bring me that over there. Here.
Which one? Oh.
Yeah, you want to do the back? We do the leak. Have you ever seen it work?
No, I mean not with a gas leak. I've used it. I've used it in class for stuff before.
Okay. Well, we're going to
Because we
try.
talked
We're
about-
not going to do that one yet. We're going to do the other one. Okay. So here's what we're going to do.
Oh, and that's what I've used it for.
Yeah. Okay.
Is the ethanol cannon.
No, ethanol cannon, but a legitimate use. I want everybody to see it. I'm running this over to my vacuum.
Oh,
Okay. Now will it show up down here on this color? Do you think, or do we need to do it over there?
you could put like a piece of paper under it or something, or a tray.
Something.
Grab a black tray right there.
Yeah, black tray. We need something dark. Use my cell phone. It's black.
Yeah, that's a good idea.
We got this rubber tube here. It's connected to the vacuum
okay.
line. So it's.
There's a.
Can you hear that?
Yep.
So it's. I did. You pick that up. I'm stupid. Been that way since the accident. So
Jake,
now I've got
what are we streaming on it tonight? If I look it up on YouTube, what am I looking for?
We're live right now.
We're live right now.
So if you
Oh,
just
okay.
go to the Midnight Science Club YouTube, you should be
Oh,
there.
Midnight Science Club. Yeah, I forgot about that.
If you open our Zoom chat, you can see it on there. Just make sure you mute Zoom or mute
Yeah.
YouTube.
So we don't get feedback.
Kenny, if you look in the chat on Zoom, there's a link for it.
Oh, okay.
I think is that about right, Cody?
Yeah, that should be good.
So I'm going to take this spark. This is called a leak detector, and you run it along the top of your car engine or something to find a vacuum leak. So this spark that comes off, well, of course, it's not going to make a spark now, is it? What were you doing over there to make the spark?
We set it on the soapstone. You think it's just because?
Oh, we
Yeah.
have to have something metal.
I can get a metal, like a pie pan underneath if you want. We got some over there.
Yeah, with some metal pipe ends.
Yeah, try metal pie pan.
Do you not have luck with the two?
Huh? No, we're experimenting. Try metal pie pan. We did this all afternoon over there on the soapstone top, and we got a spark because it's grounded. Yeah. Okay. Did you get a dark pie pan there?
These ones will work, right?
The dark, I think, a metal, this, any,
Yeah.
or I'll just have you guys go and do it at the table. Yeah, or I'll just have you guys go and do it. No, you're talking about that? I'll see here.
Yeah, we can see that.
Can you see that spark?
Oh yeah.
Oh, yeah. Yep.
So you don't stay on it.
Supposedly, these are used to detect leaks that you can't see. So, but the spark will give it away. So this has got a vacuum going in. I don't know what's going to happen. Does it go in the tube? Does it get stuck in?
Oh, there goes the steering.
Doesn't seem like it.
It's just
why not?
next to it.
We'll try it from the side here. It was working earlier. Doggone it. It would suck the spark down the hole.
Oh. Is the vacuum pump on?
Yeah, it is.
Okay.
Some of it's going down the hole. Can you see that?
Oh, just yeah. Every now and then.
Every now and then it goes down the hole. Yeah. Okay. Well, anyway. So much for that. It worked a lot better over on the black top.
Do you need to have a better ground for your pie pan?
Probably.
Because you said your lab table, it was all grounded.
You guys want here? You guys try it over there. Go plug this in over there and just see. They're going to go over to the other side of the lab.
Okay.
I'll let the we'll go over there on the black soapstone top that's got all the plumbing pipes that are grounded. So
Okay.
we'll try that.
Well, we wanted it all the way across the room.
Oh.
Oh, just right there.
That was originally the plan.
Oh.
Well, that's how stupid we are. So they're setting up over there.
I need something to hold this.
Here we go. Is there? Yeah.
Oh yeah, Jake.
What?
They do call him Jerb for short, like you said.
Oh, Gerb.
Here, you want to try this one? Look,
You got Gerb or Gerb? Gerb.
We're good?
see how it
Gerbil or Gerbil.
I think we're good.
There we go.
Okay, Jacob's got to switch the camera. Is that
Oh,
showing
you can
up?
see it there.
Oh, there now.
Yeah.
Oh yeah, is it going in the hole? Looks like I'm going to have to work on this
Yeah, there. Right. You can barely see it.
one. Okay. I need to increase the vacuum, don't I?
Yeah.
All right. Well, Gerb or Gerb, we're trying to get. That's why we're doing these things online now, is to work out the bugs, so I don't look any worse than I do already when we do it for kids.
Are we done with this?
So we need to work on that.
You can bring it back.
All right, bring it back over here.
I'm gonna
This
put-
is the real reason for this thing. This is the reason this was developed, I'm sure. We call this the Cape Escape. Yeah, baby. So I've got a little bottle. This is called the Scotty bottle. And down inside, you can see there's a piece of an old extension cord, right? Okay, and I glued it through the hole in the bottle. So I've got down inside, I don't know if I'll hold it still. Can you go down in there? Let's see if we can focus down in there. You see the little V shape right there?
Yeah. Okay.
That's so there's a little spark gap down in there. Like a little spark plug.
Okay.
Okay. So you want to squirt in some, what is that?
Isopropyl alcohol.
Isopropyl, but the concentrated stuff, not the
91%.
91%, not the 60.
Never
Good
the
stuff.
90.
Yeah, squirt that in there. Yeah, a little bit. Shake that around. Think that's enough?
Good.
Huh?
Okay.
Good. We gotta shake it around though. Gotta mix it with the air. Yes, sir.
Kenny, have you ever done this one?
No, this I haven't
Okay.
done.
Have you done this, Kenny?
No, I haven't.
So you get a. I like these Nalgene bottles just because they're tough, but you don't
Oh,
have
yeah.
to use stuff. They're tough, right? Well, I use a plastic bottle. I put a couple strips of tape around it just in case it did split.
And you're supposed to put your head right over it when you do it.
Yeah. Then I'm gonna put a cork in there. And I put this balloon on there only to make it easier to see the motion of the cork. It's just a hat.
Oh, okay.
That's just what it is. And I'm just going to touch one of the two wires. I think it's grounded, air grounded enough to make a little spark in the side. See what happens. Now, what are you looking at? The cork?
I'm looking at the whole thing.
You're looking at the whole thing. Okay, here we go. 3, 2, 1. Yeah. Sweet. 20-foot ceiling, hit the ceiling, hit the roof. This is what we do for fun.
Reload.
Reload.
It's really important to use a cork instead of a rubber stopper,
Oh, you're just.
Why is that, Scott?
because the rubber stopper comes out pretty hard,
Well, let's shake it up
and if
with
it
some
hits
air.
somebody, it's not good.
Blow some
But if
fresh
you
air
use
down in
if
there.
you use like a regular cork one,
That'd be more fun though.
it's a lot less dense. So even, I mean, it'll hurt if it hits somebody coming out of the bottle, but
Yeah.
not nearly as bad as a rubber stopper does. It's not like I'm talking from experience or anything.
You want to try it, Whit?
Sure.
Okay. Put that there. Just bring it up there. Okay.
More alcohol.
No, let's see. What do you think happened? Hey, listen, the Whit's going to figure out why did it not fire. Oh, shit.
Well, did Elliot? Did it turn the TV off again?
No.
Okay.
Look,
Did Elliot not put any alcohol in
down
there?
the tube, huh?
Elliot or Beckett put alcohol in
All
there.
right.
What's the deal?
What is the deal?
Must not have mixed the air and the alcohol well enough.
Yeah, what's one of the products of the combustion? Carbon dioxide.
Yeah.
And what? There's another one.
Smoke.
Smoke, water.
Water.
There's a lot of water vapor in there
Mhm.
from that prior thing that will muffle that a little bit. So
And not a lot of oxygen.
not a lot of oxygen. So I sometimes have to flush out the.
Why can't you just blow on the top, Jake?
We did.
Yeah, but why doesn't that work?
Oh.
Jake, you're not drinking that alcohol, are you?
No, I'm blowing.
Oh.
Blowing the exhaust out there.
Yeah.
Put a couple more drops in.
I don't know. You could probably. Can you squeeze the bottle,
You could. Well, not this one's pretty tough.
or is it too? It's too thick. I know some of those Nalgene bottles are pretty tough.
Yeah, pretty tough. How do you ignite it without a sparker?
I don't know.
Yeah.
You can get a barbecue piezo.
Oh, yeah.
Barbecue.
Oh yeah.
And you.
I've done it where you just put 2 nails in, and you can hook the grill igniter up to each side.
Yeah.
And the 2 nails, you get them inside the bottle so they're close together like the wires are.
Yeah. Here we go.
And you can get a spark across there.
Here we go. Come on, go boy. Well, you're just no good.
I know it's my fault.
You're sucking your
Yep.
vibes are sucking
I
the
know.
sparkle.
That's what I do. I just suck the vibes out.
Gee, my gosh, dang it.
Keep setting it down on the button.
There you go. I don't know why that didn't work.
More alcohol.
We might have gotten the wick wet. Whoa, wait. We'll come back. It did work once, right?
Yes, I saw it.
Okay, because these people got to go. We got to do things.
I know.
We can't keep messing around,
Gerbil has things to do.
you know. Well, Kenny, you've never seen that, but it's good. Normally it works. We did it in Saudi Arabia for a week-long seminar, a science festival, and those kids were shooting these things up by the hundreds. And it was probably, what, a 40-foot ceiling, Jacob?
I think it's more than that, but yeah.
And the idea was, how high can you make the cork go without touching the ceiling? That was the
Oh,
competition.
wow.
That's tough.
And they were working on how they control how high.
Well, what they would do was they did different things, like how many drops of alcohol they'd track there,
Yeah.
and then they would warm the bottle up to
Mhm.
see if it was more vapor. They
Okay.
tried all these different tricks to
It's important to note, though, that we didn't have isopropyl alcohol or methanol.
what did we have?
You don't remember that?
Oh, we had we had ethanol, but
Okay.
but we used
methanol.
Menon's aftershave.
Okay. Oh.
You know, so this might get loaded down with water vapor. I don't know.
Mhm.
I imagine that's what it is. It's not working.
Dang.
We'll come back
Hey,
later.
you might, if you take the cork, well, if you take the cork out and see if you're getting a spark across there still.
Oh, look inside, see if you can get the.
Yeah.
Yeah.
But without
with-
the cork
with-
in it.
Yeah,
without the
obviously.
cork in it at a distance, right? Because I'll look, I'll go.
Right.
Hey,
Yeah, I don't want
fire.
you to. Yeah. But just to see if you're still getting a spark
Zoom in
across
there
your
and
wires.
see if you're getting
Yeah.
any fire in there. Yeah, all right. Yeah, I'm gonna put a little weight behind it. So, okay, are you focused on the little V?
Yeah.
Yep.
That
Oh,
would have
there.
done it.
Yeah.
That one would have gone.
That would have gone.
I don't know
Would have
what.
sent it.
You saw it that
You're getting
time.
plenty of spark.
Okay. And that one it would have fired up, right?
It would have.
Yeah.
Yeah.
We loading up again or not?
I'm gonna blow some more air in there. Oh shit, that's pretty good. Just don't get it on the. Did you get it on the thing again?
I don't think so.
Okay. There you go. Now you got to save because all these people are watching. You know.
Yeah.
So there we go. Put your thing back in there. This is for you to get. He's got to get his width points. He'll never make it to wizard if
Got to
he keeps
redeem
messing up.
myself.
I know. Here we go.
Oh my gosh. I'm just terrible.
It's sparking. It's sparking. I see it sparking. Okay, you got it. Never mind. I wonder what that is.
There must not be enough oxygen.
That's got to be it.
It's got to be it. It's fuel. We got not enough oxygen.
Yeah.
All right, we'll let it cool down for a while. We'll come back. Okay, moving on. Kenny's
Next.
got things to do. He can't sit around here all
He's
day.
a busy
waiting.
guy.
Huh?
He's a busy guy.
Now you were named at. No, I'm not going to say your last name. I don't give about anybody's last names because I don't want you hit up by people on the cell phone going, "Hey, whatever." Is that what we do? Let me check
Yep.
my notes here, see what else is going on. You know, I'm tired of this thing. I want a bigger transformer. To heck with this thing. You got a bigger one?
I think so.
Let's get rid of that
All right.
lame old duck. Because we're going to end this show with a bang. I mean, this presentation. I've got something really cool. But I do have to stand back now, guys. That's why I have to have him here because I had a little deal put in my heart. It's a
Oh,
little monitor. It's a
yeah.
little monitor. It's not. It's not. Oh, now we're talking.
This thing weighs more than I do.
Does it?
Maybe.
Yeah. Let's
And yet
set that
Beckett's
up.
still able to pick it up.
Yeah.
Now this is a transformer.
Oh, yeah. Are we doing your ladder?
Yes, we're going to do my ladder, but we're going to do a
Woohoo!
modified version of it. We're going to do a modified version of my ladder. Turn that off. There we go. Jeez, I got to watch out.
So this isn't actually, I mean, it's physically larger, but what's the ratio on this one?
Okay, this one is 15,000 volts.
Okay, the other one was 3,000, or was it?
Yeah, but a much lower amperage.
Okay, yeah.
Yeah, this is 30 amps, 3.8 amps. That's quite a bit at that many volts. Yes, sir. Wow. Woo! 15,000. Oh, we got to put this together. So what are you doing?
Where do these go? On here?
Yeah, here we get that. You
Yep.
got to get that loosened right there. Not sure it is. Be on there. We have a 15,000 volt deal there. There, got that on there. Okay, now.
You ever made one of these, Kenny?
No,
You know,
take everything
you know
out?
what it is, though.
Loosen it.
no, I really
Jacob's.
don't.
It's a Jacob's ladder.
Yeah. Now, so I've
If you
got
ever watch any of the Frankenstein movies,
Is
there's
it
always
in-
one in
in
them.
or out? In.
Yeah.
I've got one up in my barn
Get that
loft.
up on the screw.
Oh yeah.
Yeah.
What do you mean?
What
I was afraid to leave it at school after I retired.
Oh, it
Yeah.
Oh, I see. Okay.
Yes,
Now,
sir.
what do
They're-
you need them for?
Huh?
Between
what
the
do
two
you-
They're
washers?
just really
Yeah,
cool.
something. Yeah, it's got.
I mean, it's not. I mean,
There you
And
go.
when I taught college,
There you
we would
go.
talk
Tighten
about
that down.
what kind of voltage you need in order for a spark to go across for an air gap.
Yeah.
Yeah. Come on. Okay, that's good enough.
Is it?
No, tightener. A little more tight. Sorry.
Scott, how long did you teach college for?
8 years after I taught high school for 30.
One more.
Yeah.
Yeah, that's it. That's
So-
this one over here.
How long have you been retired?
There you go. Now let's put that-
From college, just this is only my second year. So
There we go.
Okay, I'll tighten that. 2 hands better than 1.
Yep.
Okay, there you go. And the width tightens it on there. Okay. Yeah. I should get a nut driver instead of the wrench, shouldn't I? Okay. There we go. There it is. Would you grab one of those plastic fingers up there by the door?
Yes.
Yeah. I need a pointer.
and you need to back up.
The one with the
I get both
aluminum.
of them. Yeah, both of them. What do I need to do?
You need to back up.
I do?
Yeah, the last thing I want is for you to get.
Oh, listen. Yeah, but I got a lot of life insurance, so I'm fine.
Yeah,
Carl is fine.
yeah, right. She'll be okay regardless.
He'll be okay regardless.
Let me give me that aluminum one here. I've got a little finger with aluminum foil on it
Oh,
in case I need to put it in there to help it get started. 15,000 volts, right, Scott?
I thought that's what you said. Yeah.
Yeah. And the spark will jump at about 25,000 volts per inch. It's kind of the standard thing, about 25,000 volts.
Yeah.
Okay. So I'll just flip this sucker on. Let's see what happens.
You want me to turn that fan off?
Oh, come on, baby. Got to get warmed up a little bit. That's kind of neat, isn't it? Whatever you're going to do with that, I don't know. That's called a Jacob's ladder, right?
Yep.
I think it's blowing because the air conditioner's blowing that thing. It's not doing it very. Hand me that plastic one, man.
Will it go clear up to where you've got it spread out at the very top?
Yeah, it will. It will when the wires get warmed up a little bit.
Okay.
You know.
Well, there it's starting to.
Yeah. You can tell which way the wind is blowing in this room just from the air conditioning. You know what I mean?
I think it's
Blowing
that
the spark
fan.
up. Yeah. Yeah, that's all right. And that's pretty good, 15,000 volts. And that would be enough to satisfy the normal person, wouldn't it? Just to see this. Are
Oh,
you
yeah.
satisfied?
Yeah, I'm satisfied.
It's satisfied.
Are you saying there's more, Jake?
Yes. Because, I know the electricity is traveling through this wire here at 15,000 volts, but I don't see anything around here. All that electricity, 15,000 volts, I don't see anything going on right here. I don't feel anything, nothing. You just say, well, nothing's going on except that spark, right? I mean, that's the main thing that's going on here. But that's not really true.
Well, yeah, there has to be something happening in the wires.
Because we've got 15,000 volts of electricity going through this wire, right? 15,000 volts. And it doesn't.
And then it's jumping across.
It's jumping across. But I look at the wire and I say, well, I can't tell that from a dip. Here. Now you can't tell there's anything going on. So I turn this back on. Spark gives it away, but
It's moving now.
it's moving now.
Yeah.
Yeah. And by the way, am I seeing the electricity? Is that what electricity looks like?
Yes.
Electricity yellow. That's actually the air that's glowing.
Oh.
Yeah.
The air is getting hot, but the electrons are so small you wouldn't see them. But it's the air that's getting heated up. But man, I don't know.
I don't
how,
know. I don't know if you could pick that up with an infrared thermometer,
Maybe.
or I bet with a if you had a thermal camera,
Mm-hmm. Well, by golly,
that'd
we've
be a little
got a
bit more
way.
than anything I've had.
We've got a way to do this. Now it's going to take just a second. I'm going to have you come over and get rid of this thing
Yes.
and pull over we call it the Noble Agenda. Just roll that over there. You might have to grab it down below or pull it over here.
Or like up there.
Just park it right down here. We're going to get to it. Yeah. Get that right up there. Yeah. Yeah, now we're talking. This is going to be kind of dangerous.
Oh, good.
Yeah, I don't know how we're going to hook this up without me getting shocked, but we'll find out. This wasn't too well thought of. Let's see. I've got to scoot this over. Oh, we got more cable. Yeah, we got more cables. So we're going to take this this guy right over here that we had, set him right in front of these fluorescent tubes, and we're going to take this wire. And can you see the yellow wire? It kind of just laces around
Oh,
the
yeah.
outside tube. That's all it's doing is just laced around the tube.
So it's not connected to anything.
Not
It's
connected.
just landing.
But I am going to connect it right here to the
Okay.
thing. You know. Now, how the hell am I going to turn that on?
I can turn it on if you want.
Huh?
If you got to get back, I can turn it on.
Yeah. No, see, I just want to get these away. Scoot that a little bit closer to you, just a little bit. Use your feet. Yeah, just get it. Yeah, there you go. And you can back it that way a little bit. Now we got the wires tighter, so just keep going. Just back it up, back it up, back it up till we run out of wire. There we go. Okay, there you go. Now we're talking.
What about these two that are loose up here? Where do they go?
They just hang.
Leave them? Okay.
Yeah, so now you can see, ladies and gentlemen, that we have our same two wires that go making spark. That we've got connected to these ones that are just laced around the fluorescent tubes. And you might say, not being a scientist, you say, well, these things are not connected to anything. Right?
Yeah. No, they're not.
We're going to have to dim the lights in the studio. Is that going to be possible?
Yeah, I can do that.
So I'm going to fire up the light here. See if it finds. Okay. I don't see anything going on. Yeah, there aren't air conditioner winds blowing.
Yep.
Okay. Nah.
I see it.
Oh, yeah, there it goes.
Yeah. Isn't that cool?
That is cool.
And you know what's amazing is that demonstrates that there is a field around the outside of the wires.
Yep.
And it's the
What-
field
Hey,
that moves.
Jake, what gauge wire do you have around the light bulbs?
Oh, that's probably 20 gauge or something. 22.
Okay.
Just
I'm
10.
wondering if you went like 18,
I have no idea.
if that'd make it a
And I
little
suppose
better.
if I scooted the wires closer together, but it's just making the phosphors glow, right?
Yeah.
Right.
Okay.
I think you could have done that with your Tesla coil too.
Yeah. But the neat thing is, it's the field that's around the wires that's doing
Yeah.
it. You say, what field are you talking about? I don't see no field. It's the field. That's what runs down the high tension lines. That's what electricity does. It's the field that's doing all the work, not the electrons inside the wire.
Yeah.
Those electrons don't move that far. They do migrate a little bit, but it's the field that travels. That,
Right.
You know, not at speed of light. It's shorter, but It's a fraction of the speed of light that goes. So now we can actually see the field around the wires. Not that anybody would care, but now you've seen it. Have you ever seen such a thing, Scott?
Oh yeah, yeah.
Well, heck, we can't.
Yeah, I haven't, Jake.
Huh?
Okay.
This is the first time I'm seeing this. I haven't seen something like this before.
Well, you know, you can do the same thing. Take one of these fluorescent tubes and go out underneath a high power line at night and swirl it over around your head and it'll light up. Because
Really?
Yeah, oh yeah. You look that up online. You go those big 100,000 volt lines that go overhead. You know, downside the highway or wherever, and you just get a fluorescent tube and tape it onto a rope real good or a cord so it doesn't fly off, and just go. And you get that thing moving through that field, and you go, look, I'm getting cancer. Sweet. You know. So let's do one more thing before we shut this thing down. So anyway, that's a good demo, right? To show that there's field.
Oh yeah,
field,
that's a really good
field
one.
around a wire. That was the main reason
Yeah.
for showing it. Is there a field around a wire? Yeah.
Would it matter if you put more wraps around each tube?
Well, that's what we'd have to find out.
Yeah.
I'm sure it would, wouldn't it? There's all kinds of variables.
Yeah.
Anyway, and all that from 120 volts. Which what amazes me is that it's just that 100. Somehow we were able to take that 120 volts and make it dance like that. But you know, these guys around here are a bunch of punks. They're not even satisfied with this.
They're greedy.
What do you mean?
What do they want you to do now?
Well, they want more than 15,000 volts.
Well, yeah, more's always better.
Well, how are we going to do that?
And what's that going to do? What do you want to do with more than 15,000
Well, you
volts?
just saw what 15,000 volts was, right?
Right.
Yeah.
This is getting scary. For safety's sake, I'm going to unplug this thing. Otherwise, I'll hit that switch and
Yeah.
we won't have to be discussed. So I think we'll disconnect these. Do you want to pull those back?
Yeah, sure.
We are going to see if we can get that 15,000 to pump up a bit without a transformer. Because we probably burn up one. And we're going to do what Faraday did. He said, can you regulate this electric current? You know, he came up with a capacitance,
Yeah.
right? And a capacitor is something that will stop the current for a second and let it build up, then let it pop on through. You know, build up some pressure, then pop on through. Now, why you would want to have that, I don't know. But the idea is that can you control that electron flow? How can you control it? One of the things you can do is put it through a thinner wire to try to slow it down, I guess, or give it some resistance. You know, that was Ohm. And Faraday was into this thing he called capacitance. You know, so he made a capacitor. I think he used wax paper and foil wax. I can't remember how he made the first capacitor. But what he did was, well, something like this. You better get rid of that flammable stuff. We might have an accident.
Okay.
Let's try one of those jars right here. I want you to see what Cody and Cortland made, Scott. They made a whole bunch of these.
They made their own Leyden jars? Oh, wow.
Do we have one that's full of pickles?
Yes, we do. That's right by Becky.
Yeah,
I
bring
got it.
that over here.
Pickles.
Yes. Pickle.
We started out with this. There, come here. This is what we started out with. We went down to Dillon's and bought pickle jars.
Yeah.
Good, solid, heavy glass.
A lot of pickles.
A lot of pickles. And those guys lined it with, where's that tape, that silver tape? We just had it here somewhere. Can't remember where we put it. Went down to the hardware store and we bought some aluminum tape,
Okay.
sticky,
Cody, where is it?
you know.
They put it around the inside.
We wrapped around on the inside. He's going to show us the tape here. There it comes. At great expense, we went to the hardware store, Ace Hardware. We bought some of this aluminum tape. There it is. And somehow they got down inside and lined the inside of this jar with foil. And then all across the bottom, the inside at the bottom is all covered. Yeah, it's all covered inside, covered. And then on the outside, they put another layer of the aluminum foil tape, but they didn't go all the way to the bottom. They stayed about an inch or two off the bottom. They didn't go all the way down. They're just this wide outside. And so what Faraday called this separation in between, because I've got one conductor outside and one conductor inside, it's called the dielectric.
Yeah.
Yeah. It will conduct electricity, but it does not do it very well. It puts up a fight. You know, I guess everything will conduct electricity if you get the voltage high enough. You know, but this doesn't. And so then they went and got this is kind of cool. Look at this. They got a circular bit and cut out thing. And then they got another bit and cut a groove in the piece of wood, right? That would just fit on the jar lid, so it kind of stay in place.
Okay.
And this chain is just a conductor, but we wanted something that, like a wire, would get a kink in it, or it might lift off. So this chain is just another conductor that touches this knob on top. And that's just a
And is that just a cabinet knob?
Yeah, cabinet knob.
Oh, wow. Okay.
On a string.
Yeah.
And there's a Leyden jar.
Wow.
And this wire, we put this up there just so we can connect several of them together. Well, you can store an electric charge with this thing. If I would do my static electricity demonstrations, I could charge up a plastic rod. I could just touch it here and store the charge in there for a while. It's kind of neat. It's called a Leyden jar. That's a very low voltage capacitor. But we thought maybe what we would do is get several of them together and make a great big capacitor. Something that will let the electricity stop. Hey, it stops right here. I can't get through until it builds up enough to jump through. Boom. And we can measure how much it will hold the electricity back. It's called impedance, I guess. It impedes the flow. Isn't that what it is? Isn't that right, Scott? Impedance?
Yeah.
Got to say that word right. Impedance.
Impedance.
That this thing impedes the flow. This is like speed bumps on a highway. Slow me down. Is that a good example? Speed bumps on a highway?
Yeah.
Kind of, sort of, maybe.
Yeah.
Electrical speed bumps. So if I have 15,000 volts coming down, barreling through there, yee-haw! Now I hit this thing, I go, oh man, slow. You got to stop just for a second. And it builds up because everything's coming behind it, wham, then it'll pop through and go. And that's kind of a very poor explanation of a capacitor, but that's what it does. It impedes the flow of the electricity. So instead of using these, we're going to use something else, don't we?
Yes, we are.
Okay, so you're going to take those off?
Yes.
We're still going to use this transformer. Yeah, there it is. He's going to take that off. Now we're going to get serious. This is getting a little scary. There you go. You just get started and I'll take it off. Okay, there you go. There you go. Take that. There we go. You got that off there. There we go. There you go. There you go. Thank you. Lay that back on there. So now we still got our 15,000 volts, right? So instead of using rabbit ears like we did before,
Mm-hmm.
we're going to use what? Where is that thing?
Pickles.
Oh, here it comes.
Can you use these?
Huh? Yeah, we're going to. Oh, we need some serious chords here. Ooh, this is getting scary. Okay, we're going to use this. You're going to hook that up to this on the end. Somehow. Let's see which end goes where.
Use the smaller alligators on
this?
the transformer, yeah.
Okay. This one goes on here. Okay. Okay. You got it?
Yeah.
Okay, we'll get this out of the way too. And let's just throw, where's our stand? Let's do the stand first. Right, it's over there, the wood stand right over there. Pick it up right there. Right there. Pick it up at the top. There you go. Yeah, now we're talking. Here we go. Oh, hang on a second. We'll turn that around this way. So can you see that, guys?
Yeah.
Instead of having a rabbit ears going up and down, we've got this thing going sideways. And I'm going to hook this up right here. And where are you going to hook up? I think you're going to hook up above.
Oh yeah. Maybe.
Squeeze it. You got it?
I mean, it's on there. I don't know if it's gonna stay.
Oh, yeah.
Yeah.
Is that good?
Yeah, that's good.
Okay. Okay. Now I'm going to step back a little bit. You think that spark will jump across there?
Should.
Okay, I'm going to turn it on. 3, 2, 1. Yeah, you jerk. Turn it off. Oh, I didn't have it plugged in. I'm too old for this crap. You know, my heart's giving out on me, and then I'm going to think, that's not working. Okay. Here we go. Oh, look at that cute
There it
little
goes.
thing. Isn't that cute?
Yep.
A little 15,000 volt spark. But there it is. You getting a close up of that, Cody?
Get closer.
Yeah. Okay, I'll shut it off.
Now,
That's 15,000 volts.
okay. Why is it moving around though? Why did it just stay in one place?
Well, I imagine the air heats up. You know,
Okay.
and the wire heats up. I mean, it's going to
Yeah.
find the path of least resistance, whatever it is.
Mhm.
Now, I wonder if we could jack up the voltage a little bit. What do you think, Cody?
I think we can, yeah.
Now, Cody's the expert. So, Cody, why don't you come over here and just do it? You guys wired up.
Here you go. Switch out here.
Yeah.
Is this an implication that Cody's expendable?
You're darn right.
Are we just doing one?
Oh, well, should we try one?
It's up to you.
Well, you go ahead, Cody. I mean, it's fine. This is fine. We'll try one.
Try one. All right.
We're going to try. So we're just going to take one. There you're going to go.
All right. So we don't have one attached to the side for this.
Oh, there, over there. Where are they? Oh, right here. We'll just use the 3 then.
Just use the 3.
Yeah, we'll use 3 of them. Yeah.
Let me get rid of the wooden one.
Perfect.
There you go.
Okay. So nope, that has to stay.
Stay.
It stays right
We
there.
still need that. We're basically going to take it from here to here. Okay.
Okay.
So one side is going to attach to the side.
Yeah.
One side's going to attach to the top. Where's the other?
There it is.
Here?
Yeah.
Yeah.
That
Hook on one of the
hook on one
balls.
of the knobs there.
Oh, okay.
Yeah. And then the other one's going to go back where it was on the.
Where does the little part hook on?
You do a little hook onto this.
I don't
that
know
right?
about that. Are you sure about that?
Trying to remember. It's been a couple
You're
months.
not making a loop here. Yeah. You just made a circle back on yourself. Okay, so you've got that right. You've got this. This is connected top to bottom, right?
That's right.
Oh, take that out there like that.
Was.
Yeah. And one of those And where's that connected to?
That goes to here, right here on the top.
Okay, is that one right there? Right, and this one goes to the bottom,
That's right.
and the bottom goes over there. So, okay, I just want to make sure we're all right.
We are all good?
Well, we're going to find out real quick.
Okay.
Remove these cables. This.
Okay.
Take a couple steps.
Now, that was 15,000 volts, and we're going to run the electricity through our homemade capacitor. See if we can pump that up a little bit. You want to turn it on? And be ready to turn it off real quick. Go.
Oh.
Turn it off. Oh!
I can smell
What do
it.
you
So,
think?
okay, so what evidence do we have that we've got a higher voltage?
The ozone?
Okay.
The ozone? Yeah, yeah.
It seemed like it looked like it was going a lot faster,
It was going a lot faster.
and there were
There was
actually more
of them.
lines in
Yeah,
it.
There are more
So it was
lines,
sparking in more
there's a lot
places.
more current, right?
Yeah.
And you should have heard the sound. Did you hear the sound?
Oh, yeah, we could hear it.
Yeah, the sound was much greater.
Yeah.
Check out the TV.
That's why I'm sitting all the way over here.
TV
Yeah.
turned off again, too.
Ozone. Isn't that cool?
Yeah.
Now we're going to stop there because I don't want to take the time to hook up 3 more and get really crazy. Maybe we'll do that next time. But that was the whole point was you can manipulate electricity to do things, right? And that's what the idea is. And electrical engineers, what are you guys doing? Well, we're learning how to juggle electrons to do different things for us.
I don't know, Jake. Could it go even bigger?
Kenny,
than
do you
that?
get to do much electricity with your kids?
We used to, but they changed the curriculum, so now we don't.
Oh.
And we enjoyed it. We enjoyed, creating circuits and doing this and doing that.
Yeah.
But they changed everything, so now we don't.
No.
Now we do a curriculum called Open Sci-Ed, which is which is what they call storylining, where they focus on a narrative and then do experiments around that narrative.
Okay.
It's not terrible. I enjoy it, but we lost a lot of good things we used to do.
Yeah.
Well, this would probably be fun for just, you're afraid of lightning, and what is lightning is, it's the air slapping back together. So this is the closest thing I can make with a lightning bolt. And that loud.
I know.
crack.
You get a Van de Graaff generator, you can get some pretty good sparks off it.
Well, yeah, that too. But the sound of that crack, 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 that's thunder.
Mm-hmm.
That's thunder. We just made some thunder.
Yeah.
Yep.
Turn it on one more time. Fire it up. Let's see what we got. There we go. Let's make some thunder. Oh, baby. Wow, that's wild, man.
Hmm.
Whee, doggies. Okay, we got it. Oh, that's loud. It was really loud here.
It was loud enough over the speakers too. So.
Well, that's all right. Well, that's pretty much it. I don't know how I would work that into a curriculum. How would I work that into a classroom thing?
That'd be hard. I mean,
It would. It's
I
good as a
wouldn't either.
demonstration.
yeah.
Well, obviously, yeah.
But that's why it's like a standalone demonstration, in my opinion.
Mm-hmm.
It's a wow factor.
Yeah, I don't know how you could incorporate it in, like if you were actually doing circuits. Hmm.
I don't know, but it's like, it's just like, what's amazing is that we used 110 volts out of the wall socket to do that.
Yeah.
The same stuff we do our stuff with, we just did the same thing. And how did we manipulate the electrons? With foil and pickle jars.
Mm-hmm.
That's the deeper point I would try. Or it's more of an attitude setting thing. It's like, I could actually, in my little grubby way, do these great manipulations.
Mm-hmm.
All these great, wonderful things don't have to be at Harvard. Because I remember every kid that's
and
every kid
you
that
can buy those jars already made. You don't have to
Well,
eat all
yeah.
the pickles.
Well, if you're a wussy, if you're a wussy, yeah. If you're a wussy.
Oh, if you really like pickles.
Yeah. Well, and the
But
other one,
the ones that are those white ones sitting around. Do you know where that is, Cody? So I went online and I bought some. This is what sold today out in the garage. So I bought them. They were like $25 from blankety blank Scientific Supply, right? You know, Leyden jars.
oh yeah.
And this is here we go. Yeah, show me that thing. I got that in the mail. I went, this is not going to happen. Look at this. Look at
Oh
that
yeah.
little bitty thing.
Hmm.
Of course, you're not going to stop your heart with that. You'll get a little bite on your fingertip, but
I think those seem a little more Carla approved to me.
yeah, Carl approved.
Yeah.
But when a kid sees that, they'll remember that the rest of their life.
Yeah. Oh yeah, with the sparks and everything.
Yeah, they'll remember that the rest of their
Yeah.
life. And that, whatever that is, I'm trying to build these Faraday 200 activities so they have the same life memory
Hmm.
insert into their psyche without it having to be explosives and fireworks. Now this wit here, it's got to be exploding or he's not going to remember it. I'm sorry.
Yeah.
It's just
If it ain't exploding, I ain't
fire.
going.
I'm not.
I don't know. There was some serious popping on this one.
Yeah.
Wouldn't quite call that an explosion.
Now, did you guys do electric pickles with all the pickles you had to make the jars?
No, they ate them, most of them, but we,
Oh, you ate 'em?
the last time we did pickled pig's feet, that was nasty.
Oh. Kenny, have you done the electric pickle?
Have I done the electric pickle? That's a great question.
It's an actual demonstration. It's not a dance or something.
No, I know what it is.
Yeah.
I believe I have. I'm just trying to remember when I did it.
Okay.
It was a while back. Yeah, when we were teaching physical science, and that
Yeah.
was a lot. Yeah, we
Well,
did.
I thought that
a
was
lot
your
of
name
fun.
when you were an exotic dancer. You were
Yeah,
the electric pickle,
that's
right?
my line. Yeah, what's that?
That's when Jake was an exotic dancer.
Yeah, when I could move faster.
Yeah.
Well, okay, enough messing around. We did enough damage tonight. We'll pick out a top. What do you think we ought to do the next one on? What's the burning subject in science education? We need some good demos for. Is there a hot
How to be a
topic in
teacher.
science education that people could use some good demonstrations for? I don't know.
I'd say mechanical advantage, but I don't think it's in there. I don't think it's in curriculum anymore. Do you do anything with mechanical advantage in your physical science class?
No.
And I can't figure that out. Like simple machines, I didn't even do it with my college physics kids.
We did
we
simple
talked about
machines my
mechanical
freshman
advantage,
year.
but nothing about simple machines or anything. So comes up a little bit when we did torques, but
We had a unit on it when I took physical science.
on simple machines.
Yeah.
Oh wow, okay,
Oh, you're an exceptionally fine person.
yeah.
We did one. This would be a good one. We did with a cowboy trying to break his friend out of jail,
No,
right? And he had a long rope, and he tied the rope onto a couple of bars, and then tied the other end onto his saddle and let the horse pull, and the horse could not do it.
Mhm.
He said the horse was doing the best he could, but he just could not pull that pipe out of the wall.
hmm
So the science teacher came along and said, see that tree over there? Tie one end of the rope on the tree, run it through the bars, and then tie that to the horse. And the question is, will that make any difference?
Depends which way the horse walks.
Well, but suppose the horse pulled just as hard as it did before. It was
Right.
straining the same amount.
But it depends which way he's going. If he's going towards, away from the bars, or towards the bars.
Oh, don't be a smart aleck. He's trying to break out. Get out. That's what science. See, that's a science teacher joke. It was so bad that he thinks it's good. That's what science teacher joke. But it would double the pull.
Oh yeah.
And if he went around another tree and the bars again, and the horse, it could get 4 and 6 and 8 times the pull. And that one horse could pull the bars out.
Yeah, that's what my physical science kids in college. They were amazed when I brought in a block and tackle. I had a little bosun's chair, and I had a place I could hook it up, and these little tiny girls would be able to pick me up. I'm not a little tiny girl,
And,
so
and what's you know, and the only
Not anymore.
I'm almost Jake size.
Yeah. Oh gosh. Yeah. Well, where did all that extra muscle come from to do that? Well, you know what you do is you put a spring scale at each point,
Oh yeah. Mm-hmm.
and you see it, and you say, "Why? Over here it's pulling 50 pounds, but over here it's 400 pounds." All those guys are pulling together.
Mm-hmm.
Is that tree pulling when the rope's not tied onto it? How does the tree know when to start pulling? That's what's the deal. It's the mess up. It's got to explain that. Well, anyway, I'll let you guys go. You don't have any ideas for the next one, then we'll come up with them.
Okay.
Think about it. Mechanic. Okay. Well, but simple machines might be a thing that's left out
Yeah.
of the curriculum. Because what I want to do with the 200 is to say, okay, what parts are kids not getting anymore?
Mm-hmm.
And let's make a really whiz-bang activity out of it so that they'll, I don't know if it would be possible, but when you have a bunch of 7th grade kids sitting around at tables doing these activities, at the end of the day, what do they walk out the door with in their head? You know, what
I really want to see that video from Olathe
yeah,
that you got. When
I will. When they get it edited, yeah.
Yeah.
But what does a kid remember when they walk out the door and say, okay, and I bet you it's just this much, but it's in
Yeah.
there. The question is, how many
But
times
even
you
if
have-
there's anything,
yeah. So how many times around the tree do you have to go to get this? And I say, could we go directly to that and get that put in their head, whatever that is?
yeah.
And that's what we want to do with the 200 is say, hey, we got 200 bits that if you pound a kid with it every day, once a week for 4 years, at the end they'll be thinking like a scientist and said, you know, I didn't go to 7th grade science, but I got a 7th, 8th, and 9th grade education. I mean, what's in my head is equivalent to, maybe I'm dreaming, I don't know. But I imagine one day in Kenny's classroom would be like 10 anywhere else.
We do have fun. I will say that.
Oh, the greatest gift is when you're done with your science class, kids walk out there with a headache, needing oxygen. They got to put their head between their legs to get to the next class, you know. Oh, that's right. My head hurts. I had no idea my brain could do that. Oh, my Lord save me. We don't have a picture of that little boy, do we, from Olathe? No. I don't know if I told you this, Kenny, but we had one kid that sat through our first little experiment. Did I tell you about the kid with the earphones on?
No.
So we went through and took some of these activities and we sent them to Olathe High School, upper elementary school. And Olathe is kind of the hoi polloi place, isn't that kind of the ritzy ditzy?
Yeah. That in Blue Valley.
Blue Valley and Rolling Ridge.
Yeah.
Next to the golf course is the elementary school. And the principal brought in the exact politically correct
It
one
was a
African
cross
American
section
kid,
apparently.
one Asian kid, one white kid, one black kid, one brown kid, one purple kid, one boy, one girl, one kid with no head, one kid with 2 heads. We had the whole array. And she said, well, Dr. Jacobs, you've got 20 minutes. Let's see what your stuff will do. And they did it. And one of the little boys had earphones on because he was ADHD really severely. And they said he can't stand outside noises. He'll start twitching and having fits. About 15 minutes into it, he took his earphones off and they'd never seen it before, and they were jaw dropping. And he sat there for 3 hours. 3 hours.
Wow.
Grinning and patting people on the back. He wouldn't allow anybody to touch him. You touch him, he'd scream, yell, and twitch. And he was one of the guys, one of the guys throwing paper balls at each other. It's like, oh, this is great. Just from doing this stuff.
Wait, so you did a 3-hour tour with them?
They were supposed to be there 20 minutes, and the teacher said, you can go longer if you want. And I said, we'll keep going. And the cameramen were there ready to shoot. They documented every step. And they said, how long have we been in here? He said, the buses are outside. It's 4 o'clock. We started at 1.
Huh.
And those kids didn't get up to pee or leave or anything. They just, and they said, we never got to do anything like this in our life. And I thought, oh my Lordy. This was just stuff, Scott, that we had done for years.
Yeah.
That's amazing. It's like showing them a hairpin. What is that? A hairpin. Well, that's amazing. They bent it just to fit your head. Yes, they did. Oh my Lord, I didn't know this was going on in the world.
Well, Ken, you have a fun last week of school.
Yeah, we'll let you
Keep
go.
fighting the good fight.
We do our best. It's gotten tougher over the years. This will be my 27th year coming up. And the big people ask me, what are the changes you've seen? And the real change I've seen is the decline in the students' attention span.
Yeah.
With all the TikTok videos, two things. A, kids' reading ability has dramatically declined. Their interest in reading has gone to about 0, and their attention span has dramatically shrunk. And I think it's all, it's the phones. It's the fact that it's TikTok, it's Instagram, it's the phone. I mean, the phone is instant gratification. You never have to wait. I mean, those videos have been curated. When you got a video that's got, 50 million views, that means that 50 million people liked it in some form, or 50 million humans looked at this thing.
Yeah.
And how do you compete with that? How do you compete with 2 minutes of sheer entertainment, and you've got to fill 40 minutes with learning? And it's a much more difficult task today than it was 25 years ago.
Yeah.
What would you say the solution to that is? Do you see a clear path?
Well, the solution for sure in schools themselves is to get rid of the electronics.
And see,
Like
Kansas legislator just did that.
Yeah, in New York State, they made a law that you can't have phones in schools.
You mean
So
to
if you
tell
take the
me
phone out, we take it away.
that if you want to
so-
run cross country, you can't do it on a scooter anymore?
Right.
The coach
Yeah,
comes
no,
by and picks us up on his scooter if we get tired.
Right.
What if you're running cross country and you get a little tired? Well, I just flip down my skate wheels and I just skate for a while, and then I'll flip back up and start running again.
So that is the thing, to get kids' attention spans back in schools. As best you can, because I was telling kids 15, 20 times a period to put the phone away.
Yeah.
Not the same kid, but when you've got 30 kids in a room,
Yeah. And every single one of them has a phone. And
has a phone, and every kid brings the phone out.
Right.
And I would be nice about it.
or they have their smartwatch and
Yes.
for doing stuff on there.
The watches are not so much the problem. Fewer kids have them, and they don't really use them that much.
Really? Okay.
But the phone,
You can't do as much on it.
Yeah.
Yeah, exactly. The watches is not as useful as the phone. The phone is so highly addictive.
Now, so did New York just recently
This
do
year.
that?
This
So it's
year.
be for next year?
Well, no, they did it for this year.
Oh, for this year?
This is the first year we've ever had a law that said you can't have a phone in school.
Yeah.
And it was the best law they could have made. It is the single, for all the nonsense that politicians do when it comes to education, this is the one thing they did that was vastly positive.
And ours will start this next school year.
And you'll see the difference.
So we'll
The
see.
teachers-
Well,
the
it'd be
teachers will
nice
see
if
the
they had cell phones that you could. The higher your GPA, the more you'd have access you'd have with your cell phone.
Yeah.
Well, see, I came from a place where I believed for a long time that our job was to teach kids how to use the phone responsibly. And what I came to realize is that that's not possible. You're not going to teach a 12-year-old or a 13-year-old to be responsible with a highly addictive device. It just isn't going to happen in a school setting. So then you've got to outlaw them.
Yeah.
Well, sure. See, he answered your question. This guy was running for lieutenant governor of Kansas at
got
Boise
it. Yeah.
State.
I didn't
So
run,
he's
I
trying
got
to be
it.
political here. Well, I'm going to get out of here. I'll see you guys later. Thank you.
Okay. Hey, take it easy, Jake. Fun time as always.
Well, thank you, and
Yes.
we'll just keep tracking of this because one of these days we're going to be rolling the dough, and we're going to be meeting in Vegas.
I'll be 18 by then.
All right.
Hey,
Sounds
it's
good,
coming.
Jake.
It's coming. I'm not